talk I've given. I think this is a slightly less mundane version of the talk, if I remember right. Excuse me. But yeah, it goes over. I'll cover what RefactorFirst is and how it can help us as developers to make the burden easier for when we have to do large architectural refactorings and things along those lines. When the project they're working on are saddled with technical debt, how do we go about doing that without losing our wits end? Losing our ways, basically. So again, my name is Jim Bethancourt. I'm a principal consultant here at Improving. I've been with Improving for 3 years, and I just absolutely love it. And thanks again so much, Ben, for coordinating the pizza. I really appreciate it. I hope everybody's enjoying it. So the struggle is definitely real. So a little bit about me. I'm a husband and I'm a father of 5 kids. So I don't have, and I don't want to spend much time outside of working hours working on projects. And so to help me with that, to actually make the most of my time, I've invented a RefactorFirst, or I've created it, I should say. I'm also interested in software design, software engineering, and also economics. More of as an armchair economist in a way, but certainly help to inform the design and the implementation of RefactorFirst, so we can figure out where to best spend our time, limited resources that we have whenever we are working when we're performing our craft. I worked either directly in or adjacent to large code bases, anywhere from 250,000 lines of code to 2.5 million lines of code. And I've also worked with a number of tools. They're all really great, really powerful tools. Some work focus more on the class level. Some work on the large picture level, sort of architecture level. But often I would find myself feeling overwhelmed, feeling unproductive, and feeling frustrated because I would say, hey, we got problems, folks. And I'd point to these pictures and they'd go, my manager and or product owner would go, yeah, okay. But there's nothing I could really suggest that we do right then and there to make the situation better. And so this wasn't fair to me or to my family, because I would just feel pressure and almost as an ownership that, hey, we need to make this better so we can succeed as a company. But it was also causing me a lot of anxiety, a lot of distress, and this is not how we're meant to live as human beings. We should enjoy the company of one another. And so I created RefactorFirst so I could focus on what really matters. In my case, my family and my wife, and have quality time and be present to those that I love. And the large code base is also painful. They often sprawl. So I am curious. I can't really see how many folks are in there, but how many of you have worked in large code bases before? Kind of hands. Okay, I see a few hands going up in my little viewport. Okay, what's that?
So yeah, most of the room.
Most of the room. Okay, all right. Okay. So as you know, these large code bases often sprawl. They you add something here and then you have to add something there, and people get lazy, or you have different people who've touched the code base a lot of times, and they all have their own ideas, they all have their own methods, they all have their own ways of going about and doing things, and this again leads to sprawl, and you end up with a lot of utility classes or utility packages or common or because what was it? Util, common. Those are the two that come to mind offhand, but there are others that I'm sure you can think of as well, where you have packages that are shared functionality, and these tend to be sort of almost black holes or centers of gravity that or big magnets that just draw in all of and they're used by all the other classes, and they call a lot of other classes too as a consequence at the same time, and they become this huge problem in a lot of code bases. So yes, you're trying to remove the sprawl, but it only makes problems worse. And so as a result, developer productivity is really poor. And to accomplish something, you have to frequently either look at a very large file. In some cases, there was one I think that I was working when I was working at a bank a few years back. One class was 5,000 lines long at least, and changing it was very difficult and scary, really, quite frankly. But it was also the almost the sort of the heart and soul of the application. It seemed like that's where everything happened. And if you change it to no, heaven help you, you have to go and do a full regression on the entire application. So so developer productivity is poor. We can't deliver as much value in circumstances like this. And developers and architects also probably aren't able to identify the root causes of the degrading team productivity. They might have some ideas, but without help, they can only make educated guesses. They can't point with a laser pointer, this is our problem, or this is where we need to attack first to remove the problems of the developer productivity that we're facing. And so the other problem that we as developers often face is that customers expect the same velocity that the team can deliver as the code base grows. What they don't understand is that technical debt accumulates, and product owners often pressure developers to deliver features faster. And what ends up happening is that developers, well, they might take a few shortcuts here and there, a little bit, but over time, they add up. You have this sort of accumulation of negative invisible value. So if you think of features as positive visible value, then technical debt, and you think of bugs as negative invisible value, and you think of frameworks that we use as developers like Spring or Java EE or Helidon or all these other kinds of frameworks, they are positive invisible value. They help us to deliver projects and products so much faster. Well, you can think of technical debt as negative invisible value. Well, but it's something that's almost kind of, again, invisible, because the product owner hasn't ever quantified it. They haven't, the project manager it hasn't been quantified to them. They don't know how bad it is. They don't know how much is slowing down the team. And so when you can have a tool that can make that invisible visible, then they can quickly get an idea of how bad the situation really is. And they can make informed decisions along with the architects and the developers to start to pay down some of this debt in earnest. So that way the team can deliver value like they once did whenever the product or the project initially got underway. And Agile is also a fantastic process. It's a process that focuses on visible value, though, which is features and bugs. And invisible positive value, again, is the frameworks that we use to help get these projects up and running quickly. But the technical debt is this invisible negative value, like I talked about earlier. And it's largely ignored by product owners and by managers because they don't know how to quantify it. And so they say, well, let's chip away at it. But of course, a lot of times, whenever this technical debt is brought up in prioritization meetings, it gets pushed out by product owners. And so it's hard to really say, look, no, we have a situation here where our productivity is degrading. We need to speed it up. And so again, it's hard to prioritize technical debt. And again, as I mentioned earlier, product owners don't take ownership, and it really doesn't end up in the backlog either. And so what my hope also is with RefactorFirst is to give a name to be able to prioritize the technical debt that teams encounter, and to so that way it can actually get paid down. And code analysis tools are often overwhelming. I don't know if you've ever run Sonar Cube against your code base, especially the large code bases. It's like getting shot with a shotgun. You get shooting a shotgun. You just see all these different issues or priorities that need to be paid down. Oh, this will take 5 minutes. Oh, this will take 30 minutes. But you have critical, high, medium, and low. But there's no real gradient as to what ordering needs to happen. Even then, when you do run them, you see the results. It's like, okay, we have 5 years to actually pare this technical debt down. There's no way we could possibly get rid of it all. And also, they tend to focus on tactical improvements. Again, I don't know about you, but that's certainly been my experience, where they focus on sort of the line level improvements, like, oh, this method has a return value, but that return value isn't being used, or you have 7 or you have 9 or 12 parameters to this method. Yes, that is an issue, but it's not impacting the team's productivity into account. It is a problem, yes, but it's not something that's slowing the team's productivity down. And also, in almost all of these tools, the change history is not taken into account. Again, SonarQube doesn't do that. PMD doesn't do it. Find bugs or spot bugs doesn't do it. So this is a dimension that is really missing, and is incredibly helpful when we need to prioritize technical debt. You want to have the team work on the item that's going to basically have the most bang for the buck, to remove that debt first. And so these tools are also tend to prioritize only by severity, but not by effective use of time. And so again, it's yes, take care of your criticals. Definitely consider taking care of your highs, but also prioritize accordingly. So they these tools tend to focus only on a developer persona. It's something that only the developers would understand. You show these the list of bugs or the list of the fix list to a product owner. They go, okay, yeah, go fix it when you have spare time, I guess. But that's really about it. It doesn't really provide much in the way of an informed decision or guidance to a product owner or to the stakeholders. So there are architectural analysis tools. This is the Jenkins code base. This is from hellotomorrow.com. They have a great community edition of their tool called SonarGraph. And it's a really nice tool. I've used it a number of times. I continue to use it for identifying dependency cycles. So again, these tools identify dependency cycles, but there's no immediate indication of the best place to start. So if you were to look at this, would you quick show of hands? I guess who's confused by this?
You got most of them as well.
Okay, thanks. So there's no real immediate indication of the best place to start. It just says, congratulations, you have a mess. And that's really about all that it tells us. So they often these tool vendors, they say, well, the best time to start using this is at the beginning of the project. But also, sadly, for most projects, it's usually too late. You have situations like Jenkins where you have no idea where to start, and you just have to pick some place and hope it's a good one, and that's about it. And so there's also source code repository analysis tools. This one right here is from the Elasticsearch analysis done by codescene.com. It's in their showcase. It's quite nice. But again, they have a slightly different analysis approach than what I take with RefactorFirst. So the source code repository analysis tools provide a powerful Git history analysis. However, they tend to focus only on the direct churn and of the code base of each individual file, and also the PR cycle time. So how quickly did a PR get approved? And they also tend to focus, not all of them, but they tend to focus on the performance of individuals, which is in a lot of cases the wrong thing to measure, at least in my opinion, because then when you're looking at, say, how many lines of code did a developer write? I don't know about you, but that's a terrible metric. I recently came across the idea of replacement value, basically. So if this person left our team, how much of a productivity loss would this team experience, basically? Because this individual might be coaching other individuals. They might be doing the pairing in pair programming sessions, and the other person would be the one person who's doing all the commits, and the person who's pairing with them gets absolutely no credit at all, which is a shame. It's a travesty, really. And so so again, the performance of individuals is really the wrong thing to measure. And also, in a number of cases, many of these tools don't identify the root causes that are present in these code bases, and they just identify where the hotspots are. And then in this case, you have where is it? You have, like, with this particular tool, CodeScene, they focus only on the absolute churn, which ones have which specific files have the highest churn. In this case, it's these right here only, right here, the ones that are dark red. But it has more of a recency bias rather than more than anything. Whereas what you want to do is you want to look at the life of the code base across the entire individual file relative to each of the individual classes. So why RefactorFirst? So I'd created RefactorFirst because design debt is what really slows teams and team productivity down. But I wanted it to be easy to understand by everyone, by developers and by product owners and by managers alike. And I also wanted to provide actionable guidance, guidance that the team can go and look at a graph or read a table and know and have a clear idea of what to do. And also want to empower teams to make the best use of the developer's time, whether it's either the team deciding together, okay, you go ahead and you address that issue, I'll address this issue, or this class. We'll break them apart and we'll clean our code base up. And then also, so there are two strategies to pay down debt. So there's the first approach is to pay down the smallest debt first, and you'll see this one and the next one I'll talk about, referred to by financial planners. And if you've ever been coached by a financial planner, they'll talk about you can either pay down the smallest debt first. This is what's typically called the snowball method, which is tackling the easy debt first. And so ideally, this is your smaller debts that it allows you to get some quick wins, and you can feel good about yourself. And then the other approach is paying down the highest debt first. This is also known as the avalanche method. It takes a lot of discipline, but it minimizes the interest that the money that you spend in interest over the long term. But what if we're in a situation where we can start with the small high interest debt first, so we can combine the best of both worlds. We can pay down our small debt that's also, we can identify it as being high interest debt. So I'd like to give you a bit of background about what RefactorFirst is. So who here has heard about God classes before? Okay, see one hand maybe go up. Anybody not familiar with what a God class is? Okay, all right, great. I'm glad I have this slide in here. So a God class is large. A God class is large and complex. They have, in this case, you see 46 or more non-trivial methods. These are like non-getter setter kind of methods, basically. And they access, or they talk with, they work with at least 5 other classes. That's where this access to foreign data comes in. And then also they have a lot of large methods, and these methods don't really interact with each other all that much. So that's where the tight class cohesion comes in. So that means that the methods don't really work with each other. It might be so in other words, the class is really doing more than one job, probably almost 3 or 4 jobs. So there are 3 or 4 classes that are hidden in one class. So if you were to take and open up a God class, you'll find that it's hard to understand, especially if you're a brand new developer on the team and you're trying to really, a lot of times you're curious, you want to understand what the class is doing. Well, this breaks the single responsibility principle. So this class really is hard to understand. It doesn't have a job that it's supposed to do. It has multiple jobs that it's supposed to do. And so when you have all 3 of these metrics together, it's what constitutes the God class. And it's helpful because there isn't just one metric that is beloved by a manager that the team can program to. And so you have 3 methods, and so it can identify the character of these classes, and so that way you can identify them and know that yes, you have an actual problem. And this idea comes from the book Object-Oriented Metrics in Practice by Michel Lanza and Radu Marinescu. It was published in 2004, and they identified, I think, 12 different smells that were sort of more architectural level smells having to do with classes and methods and things along those lines. Brain method is one. Brain class is another. Shotgun surgery is another one. Those are just a few of them. There are others as well. If you look around, you'll find summaries of it as well. If you're curious and you want to learn more. So why focus on God classes? So I decided to pick God classes because they are 5 to 7 times more change prone than non-God classes are. And this table here is from an academic paper called "Comparing 4 Approaches for Technical Debt Identification" by a guy named Nico Zazworka, and he had 2-3 co-authors, I think, and they actually went through and they looked at Hadoop, and they looked at all of the different code smells that were identified by the 2 authors of the book I just previously mentioned, Michel Lanza and Radu Marinescu, and compared them. And this was before Git was available. They took and they took tags in Hadoop and checked them out and ran the analysis. And so it was very labor intensive what they did. They found that glide classes were 5 to 17 times more change prone, to some extent because they were simply larger. but also they were 4 to 17 times more defect prone. And so this is a huge problem, as you can imagine. And they're also they found to be that God class to be the biggest offender among code smells. So again, this is why I picked God classes to focus on first. And let's see what else. The removal is a key in the journey to microservices. I know Chris Richardson has actually mentioned this explicitly, that removing God classes is critical whenever you are decomposing your code bases, large code bases, into microservices. And this rule is also available in PMD. So again, I didn't want to have to reinvent the wheel, and the rule was available in PMD. And so I was able to, after doing some work, I was able to figure out how to leverage it and bring it into the calculation. So this is RefactorFirst. This is a graph output that is generated. So this is an analysis of Jenkins. It's the same code base that you looked at earlier, but my goal here is to actually provide something that's, one, a little bit easier to look at, and two, can be understood a lot easier by everyone. So on the x-axis, you have effort. So this is calculated by taking God classes right here, and taking God classes and taking those 3 different metrics and ranking them against one another for all the classes. And then I take each of those ranks and then sum them, and then calculate the overall rank for each class. So the farther right a God class is on the x-axis, the worse it is, and the more effort it would take to make it ungodly, basically, to decompose it into multiple classes. And then the y-axis is the change proneness. So for each of these classes, we're looking at the number of commits that class has had relative to all of the commits that have taken place since that class's first commit. So it's looking at almost sort of a rate of change. So there is not so much a recency bias, but you're comparing apples to apples. So if you have an old class that continues to consistently change, and a new class that's also changing a lot recently, those two will both float towards the top. And then the circle size represents priority. I'll show you in just on the next slide what the original approach was, and I'll explain why that was a problem. So the circle size is priority, with the largest circle being having the highest priority, and the smallest circle being the lowest priority. So I calculate priority by taking and subtracting the x-axis from the y-axis. So because what you really want to do is focus on these classes that have a high churn, that are easy to fix. So that way, again, the team, the product owner can get the most value out of their time, and they can feel good that, yes, I know I made a difference. So in case you're curious, this is what this was my first approach to taking and creating the RefactorFirst output on Jenkins. And so the circle size, the XY axis was the same, but I tied the circle size to the number of methods. But what ended up happening was that I'd say, hey, so what do you think you should fix first? And folks would more often than not say, oh, well, I should fix the one with the biggest circle first. I was like, well, that's not what I really wanted you to think. So I had to take a step back and rethink how I was presenting it. And one future improvement that I would like to actually make is, as you can see here, I'm performing a gradient of green to red. And what I'd like to do is take and capture the test coverage, or the mutation test coverage that's typically already present in build output, and tie that to the test coverage, to the test color, and the color and the test coverage together, because that's really valuable information. So that way you can know how much risk would be involved in refactoring that class. That's one of the next features that I'd like to implement. And I'm thinking that would be an ideal place, a very valuable feature. Would that be something of value, do y'all think, or not? Hands up.
That would imply that they have test coverage already, right?
Yes, assuming they have test coverage already, yes. But if you don't, it would show up here, because I mean, you have say Jacoco would spit out the coverage file, or PyTest would spit out a coverage file, and then you could have RefactorFirst run at the beginning. Now RefactorFirst quite nicely will run on raw source. It does not require compiled binaries to run, whereas most other tools require a jar or a class file to run. But PMD operates off of source, and so I was very fortunate that I'm able to take and just clone a repository, and you can too. You can just clone a repository and run RefactorFirst on it without it even necessarily compiling. So if you have problematic code base is not compiling, you look at it and evaluate it anyway.
What if you use transparency or opacity to kind of weight the thing that you're interested in? So
okay, yeah, that's a good idea. Yeah, I like that.
Be less focused.
Yeah, that's a good idea too. Thank you. I haven't thought about that before. I don't know. This chart is generated by Google Chart, and so I don't know if it supports that. I'll have to investigate. I love that idea. Thank you so much. Really like that idea a lot. So this again is where it started, and you can see why why I've decided to focus on priority as a circle size rather than the method count being the circle size. So I also include a table in the output. And it lists them in priority order. I'll run it in just a little bit, and I'll show you what I have revised this so that way the priority list is listed here. Instead of starting with the highest number of priority, it starts with 1, so it's very clear as to what the priority is, and then go to 1, 2, 3, 4, 5 in this case. But so icon set in this case is the highest priority, and its change proneness rank relative to all the others is 65, and its effort rank, which means it has the lowest amount of effort required, is 3. And so whenever I started out, I subtracted the change proneness rank minus the effort rank and got 52. And as you can see here, it'll also show the most recent commit, so you can understand and have an idea of just how recently was this file committed. Again, as you can probably guess, this snapshot of this image was taken about a year ago. But you can see that also you have Q class was written, has 429 commits, and is sitting right next to one that has only 17. But it was also relatively recently committed. And so I include this because it's valuable information for whenever a team is going to undertake an effort, and or you can look at it to see if you're about to implement a feature that might involve this class, for example. So you can look at the list of items that are a list of classes that are God classes. Say, hey, look, whenever we work on this feature, we should plan to go ahead and pay down some of our technical debt. we should go ahead and start working on decoupling and picking apart these God classes, for example. And I've also included coupling highly coupled classes as well. So how do I use RefactorFirst? You can go to refactorfirst.org. It simply points at github.com/Jim Bethancourt/refactorfirst. Actually, sadly, Sonotype had created a product available to open source repositories called Lift. Unfortunately, they mothballed it because they weren't getting, I guess, quite where they needed to go. But it was a neat tool, and they were kind enough to include RefactorFirst as part of that tool. Certainly one of the prouder moments in my career. And so to run RefactorFirst, you'll need Java 8. So I continue to focus on making it available on Java 8 because large code bases tend to be slow to move to newer versions of Java because they are in highly regulated environments, or it's hard for developers to convince their managers to move forward, or they're again highly regulated or a highly fragile environment, and they don't want to move if they don't have to. And also, it can take a lot of work to move forward, say from Java 8 to Java 11. There are tools that are available. I don't know if Jonathan Schneider has presented to the to CodeJug before, but he and his team have created a phenomenal tool. It's open source, actually. I've used it a few times, called Open Rewrite. If you want to look that up, check it out. It's available on GitHub, Open Rewrite. And they have a bunch of different recipes that can automate the migration of code bases from one version of Java to another, and from one version of frameworks to another. They have it for Micronaut, for Helidon, for Spring, for Java 8 to Java all the way to 17. And I'm sure as soon as Java 21 is released, they'll publish a Java 21 recipe. Quite a number of recipes, really nice. Again, it's called Open Rewrite. I strongly encourage you to check it out, look it up, and use it, if not short of abuse it. And they also have a commercial product that you can check out called Modern. Modern.io is that website. moderne.io. And so what'll happen is that so I use again Java 8 and Maven 3, and so you can do something as simple as specify this Maven goal right here. And this is actually, I apologize, I haven't updated this slide. It's 0.4.0 is the most recent release. And then you just run the report goal on this Maven plugin, and that's it. At this time, I don't support, I'm not supporting Gradle. If you're a Gradle fan, I sincerely apologize. I haven't written a plugin for Gradle yet. And so once you run it, it will run this, it'll generate this RefactorFirst report.html page. It's a static page. It'll also generate a Google chart JavaScript file that will populate into an HTML-based report. So great. Now what? You've run RefactorFirst report, and you can use a great plugin called the Java Method Reference Diagram IntelliJ plugin. This is the URL for it if you wanna write that, if you wanna type it in, but you can just simply search the Java Method Reference Diagram IntelliJ plugin. And I also mentioned this on the RefactorFirst repository README page. So if you want to just go to the RefactorFirst page, you can look at it, and you can find this plugin. The biggest problem with this plugin is that it requires that you use IntelliJ Ultimate, so that's again the biggest problem there. But otherwise, it can definitely help you along your journey. Once you've identified the God classes that are the most important to you, you can locate them and find them. You can locate them and actually have an idea of how to go about breaking up these God classes that you have. And so again, future directions. find classes that use 20+ types. I've actually implemented this. I'll show it to you here in a minute. And then also potentially classes that have high cyclomatic complexity, because they tend to require a lot of thinking, and but also, so not only finding them, but also identifying the ones that have a high churn. I'd also like to incorporate test coverage and mutation coverage. Anybody not heard of mutation coverage before? It's okay if you haven't, but anybody not heard of it? Okay, so check out pitest.org, pitest.org. It's a really cool tool. It's a drop-in tool. So if you have running unit tests that all pass, then it's simply it's as simple as taking and copy pasting a Maven plugin or a Gradle plugin into your build process, and it takes and will basically test your tests. And so it will go in, it will wiggle, and it will wiggle your bytecode. So for example, it will take and turn a plus into a minus, or a multiply into a divide. Or for your methods, if it's returning it has a return value, it'll return a null, or it'll make it void. Or if it's void, it'll have it throw a method not supported exception or something like that. I forget exactly what the details are, but you probably get the idea. And so then once it changes this, it reruns all of the unit tests that that call that method. So it maps out the execution path and runs all the unit tests that call that method, or that specific actually that specific bytecode. And then it will see and record which unit tests fail, or if there are any failing unit tests rather. And if no unit tests fail, then that line of code is not effectively tested, because you don't have a unit test that exercise any potentially breaking changes in that line of code. It's a different way of thinking of testing, but again, you're effectively testing your tests to make sure that you're testing your code well enough. So there's actually a Jenkins plugin that available that I plan to fork and leverage to make this possible. I'd also like to improve the Git analysis performance. Today, it works fine on small to medium-sized code bases, but when you analyze something like Jenkins, which has over 30,000 commits, it can take a long time to analyze, simply because it goes through each individual commit to analyze it. And what I'd really like to do is multi-thread that Git performance, Git analysis, to allow for greater use of parallelization in that analysis phase. And then also potentially a plugin IDE and a CLI runner. I'm really excited. Somebody's been kind enough to take and actually write a CLI command. There's a merge, there's a pull request that's open. I need to incorporate it. And I'm also working on reintegrating it back into the Maven site goal as well, lifecycle as well. I'd remove the Maven report because at one point it was identified that the libraries that were used to generate Maven site had a CVE bulletin with a CVSS score higher than 8, and so I thought it was better to be safe than sorry. But the bright side of it is that there is now a standalone HTML report as well. There will be soon both an HTML report that can stand alone, as well as a Maven site report, depending on what you need, what you want out of it, and also potentially an ID plugin as well. I don't know how that'll end up taking shape, but certainly possibility that I'll implement that too at some point in the far future. And also potentially multi-repository analysis. I'm not sure how I'll do this. I have some ideas, but I'm not sure exactly what how I'll go about it. But again, the idea being to give the product manager a holistic picture of how of what kind of shape their code bases are in, so they can make the best informed decisions. And then also potentially measure metrics in other languages, potentially using and leveraging framework tools from other languages that by using the Graal VM. That would be quite nice. So, and this is also based off of this is also based on National Science Foundation funded research. I think it was about $500,000 was used was granted to these authors to write the paper and all the related papers that they wrote. And so this is your tax dollars at work. As crazy as it sounds, it's really cool. And I've had the opportunity to collaborate with Nico here at the top myself as well. He's given me a lot of great ideas, and he was just over the moon when he saw that I was able to make RefactorFirst. Thank you so much. This is the end of my presentation, but I am more than delighted to show you RefactorFirst in action as well, for those of you who want to stick around. And I can also show you the code base a little bit of how I'm making how RefactorFirst works. So I guess first of all, are there any questions before I move on to the code base?
Yeah, I have one. I might have missed it. Do you have any? So I appreciate all these big visuals, and I know that we have unit testing as something that's like a feature coming down the pipeline. Is there a consideration for like risk tolerance from a business perspective? Like, can I tweak or pass in a config saying, hey, this God tier class, it's 90% of our income, or touching it is super dangerous. If there's like a way to weight that kind of stuff, or if that's even something meaningful. Like, I know I've worked with these kind of tools before, and people like, cool, check all the boxes, and there's no tests, and stuff breaks, and they have to roll back.
Yeah,
so maybe I guess in my mind, like, the more business critical it is, the lower it go down the priority.
Yeah.
Or the higher, depending on what you care about.
Yeah,
I wonder if you had consideration for that.
Yeah, no, I like that idea too. There's not a way today to factor in like business criticality, but you could certainly look at the number of callers potentially that class or that method has. Would that be a safe metric as to how business critical that particular piece of code is? Would that make sense?
I think usages would probably be a good indicator of that.
Yeah,
but sometimes you might have a relatively small class that just happens to be in the path of everybody else.
Yeah,
like your REST, like a REST endpoint or something like that. That just it's sacred, it's holy land. You can't really touch it. If you touch it, people are getting angry.
Yeah. This is awesome. I love it. And that's definitely something that I think would be doable.
Your definition of business criticality is based on the code. So how it's in the REST, everybody point to that and whatever that endpoint. So that's so critical. So that means it's business critical on that, right? You don't break it. So I know nothing about all this world of you guys in refactoring. So the tool can actually tell you how the possibility of breaking a thing that will relate to, I don't know, probably already in Jim's stats.
Yeah,
when you apply this, and this class is most likely 90%, hopefully, will not break. If it not break, that will increase your business criticality problem, decrease the problem. Well, how do you define business critical, kind of purely from a code base or from whatever it's important, how much revenue? What do you mean by that?
It would be entirely tribal knowledge in my mind. So it would be something that would have to define. Like we can track usage, we can identify all those things, but whether or not it's important or it breaks or it has number of outages, like if every time we touch this class, we have to hotfix, those type of things are going to be not something that's kept in Git, something that's kept in the code base. That's going to be something that's kept in our heads or in our Jira boards.
Yeah.
And I'm not sure you want to integrate with anything like that. But
So in your words, the business criticality is in the hands of the developers, not the users, customers, whatever, the owners.
it would be a conversation.
Okay, okay.
Thanks. Yeah, so
Yeah,
I'll show you the code base that RefactorFirst. I can kind of walk you through what over the RefactorFirst code base briefly, and then also I can run a report on a sample a sample that of code that's small enough to run quickly, but you can get a good idea of the sample output. So let me go ahead and share my screen again here. Just a moment. So let's see here. All right. Pardon the background noise. All right. So this is RefactorFirst. So let me. This is the work that I'm actually working on. What's that? Yeah, just a second. Hold on. Which one is it? Control. Here we go. Zoom in right here like that. Okay, yeah. So I'll actually start out with the RefactorFirst Maven reports. This is where all the magic starts. And this is constantly a work in progress, so my apologies. But it actually I took and added some HTML that'll be the header and footer basically in the legend. And then it starts and see. Can you all see that? Okay, you mean to go into light mode? That'd be easier.
Light mode, with light mode.
Yep, you bet. Absolutely. Just a second here. Okay. Okay. Is that better?
Yes.
Okay, good. Fantastic. I'm so glad. Sorry I didn't ask earlier.
Maybe just a bigger finger.
Okay, yeah, sure. There we go. So so what I'm doing, I'm taking and I am getting the project. I see, where is it? Getting the Git directory, and then I am taking and performing what's called basically cost benefit calculation. And so I'm getting all of the ranked God class disharmonies here, and then I'm ranking them, and then generating the output. So to perform this cost benefit calculation, let's see here. So I'm taking and I'm first performing a change proneness calculation. So I'm taking and reading the Git base directory, and then for all of the repository contents at head, whatever branch you have checked out, it's only going to read what's at head, and then it will walk the tree, and it will it'll take and log each of these, and then it'll walk until the earliest commit is available, and it will identify what the changes are between each commit, and then it will add an integer count to each of those classes, basically. So that's what this right here is doing. Between each commit, it's identifying each entry in the path, and it will, for each Java file, and it'll increment, and then it will take and for each of those commits, it will identify the commit. It'll add a commit time, and then the count, the running total for that class. And then finally, after it's submitted everything else, it will walk the first commit, because there's nothing that's been that was prior to that first commit. So then once this has been calculated, then it will take and here it'll actually take and it'll get incorporated into the all this information gets loaded into the cost benefit calculator, and it will get the rank change proneness, which is right here, and it compares again the number of it puts everything into a tree map basically. So so this tree map will allow for it'll sort based on the number of commits, how frequently, or is it some commits? No, the most. No, I'm sorry. It'll sort it based on the most recent commit, and so that's why it looks at it writes for the file, it writes the commits basically for each of those files, and what the most recent commit, the first commit was for that file, not the most recent, but the first commit. And so then it goes through and it'll find the whenever it's performing this cost benefit analysis, it's able to identify where in the tree or that first commit happened for a particular file, and then take the subtree of that commit and also the entire repository after that at the same time as that first commit, and then provide the ongoing count, the total count of the repository commits that have taken place in the repository, if that makes sense. So that's how the interest, effectively the y-axis, is calculated. And then for the x-axis, the effort ranker, it goes and for God classes, it goes and it runs the God class rule. Actually, sorry, this is the coupling between objects rule, but so it runs the God class rule. Basically, this is all this really does is call it the God class rule, and then it will report this. It'll capture this, and it will again rank them, and so it will again sort based on the weighted methods between for class, the access foreign data, and the total class cohesion. It will rank each of these across all the classes ahead individually, and for all the God classes that have been identified, and then it will sum each of these up. It'll sum all these up: the total class cohesion, access foreign data, and weighted method count for each class, and then sum them. And so, and then it will again go and rank for each of these classes against one another to make an apples to apples calculation. And so again, then you have the cost benefit calculator takes and it will compare each of these, and it will also take and calculate the priority, again, the y-axis minus the x-axis. So that's how RefactorFirst works at its core. And then it goes ahead and it generates the graph and the table. Here you can see this is actually generating the table with the table body, I think along those lines. And then I have a graph data generator as well that uses Google chart, the Google Bubbles chart, to generate the data. One other enhancement I'd also like to make that a coworker suggested to me is color blindness, because red and green are commonly colorblind, and so there are several different well-known palettes that that colorblind individuals can see, and so I definitely want to be accommodating to those individuals and to make it so maybe at report generation time you can specify what color palette that you might want to use, for example. So all this does again is to generate a Google bubble chart and to a JavaScript file. So that is pretty much the nuts and bolts of the RefactorFirst code base. See what else. Close that. So what I've got here is as a tool I take, and I did a Google search for ugliest open source Java projects, and one of them that came up that actually worked out well was one called, forgive the name, I didn't name it, but it's called Mega Bastard. So apparently there is there's a tool called there's a FTP site called Mega in the Netherlands, and so it goes and it's a big FTP site where folks can take and download stuff. And so what I'll do here, I'll go ahead and run the Maven report, or run the HTML report, and okay. I was having internet issues earlier. Thankfully, they're resolved. So it's a plugin, and so you've got, and this is available today on Maven Central, right here. And all I need to do is drop in plugin, or you can also take and call it with a one-liner as well. So say if you are using Gradle, you can take and create a skeleton POM project, and then it will go ahead and you can run the Maven goal, and then you're off to the races. So plugins, got RefactorFirst plugin. Where is it? Not pick it up. I thought it did. Just more time. Let me read it. Let me do this. See if that'll work. Okay. So I'll just try and run it from the command line, just like I've told many folks do. And also, if you're curious, this is the usage count, the download count rather, for the past 12 months for RefactorFirst. So it's I'm really excited to see that it's getting almost 500 downloads a month now. Really happy. So there it is. So let me go ahead and copy paste this, and then I will run this from the command line. And as you can see here, go ahead and paste that. And is this even working? Okay. Yeah, okay, so there we go. Won't take too long. Give it about a minute here. So see, it's identified the God classes, and now it's identifying a couple of classes, and now it's done. So what we can do is go ahead and should see. Oh, come on. Why isn't it printing out? Okay. Well, let me see if I can find it here. Actually, yeah, okay, so good. So if I go ahead and open this, you'll see this is the output for Mega Bastard. And somebody had asked if I can make it zoomable. So this is again a bit of a work in progress at the moment. It'll come out much cleaner, much better for you. Let me actually clean this. It's CSS. That's probably what it is. But anyway, so yeah, so this is roughly what you'll get. So this is the class output, and so if we're to go and we can look up main panel and see how bad that is, and look up Mega Cryptor and see how bad that is. And again, the priority here in this case, let me make this a bit bigger, is main panel.java. This is the highest priority class that we'll want to refactor if we were to refactor. As you see here, it has 317 commits against it, and it's one of the highest ranked, most highest change prone classes as well. There are some that certainly take more effort, However, unfortunately, as you can see, there are no easy choices here. There are no classes up here, which is really what you want, which you really hope for. Is you want to have something that's up here that's easy to fix that'll have a high impact. But so in this case, it's main panel.java. What we will go ahead and do, I'll go ahead and pull up and we can take a look at main panel.java. And let me pull it up. And so this is what main panel looks like. And as you can see, let's see, how big is it? It is 1,500 lines, so not tiny. So now if I were to take and go to diagrams and show diagram and pick the Java reference diagram, it'll show me, it'll take a moment, but it'll show me what the possible classes are, that what almost sort of the hidden classes where I can take in, I can decompose things perhaps. I don't know, this is the first time I'm looking at it, certainly, but you can certainly see that these would be low-hanging fruit right here. But the rest of it, I'm not so sure. It would take a bit more analysis to identify and present to the user. Yes, these are the sort of the hidden classes within this class. But it could certainly be possible. Actually, let's see if we can. So see Mark isolated. Anyway, I don't know. It's the first time I've ever, again, played with this extensively, but so anyway, enough of that. But so I hope you get an idea of what you can do with it potentially to help make your life easier. And then so as far as, at least for how to get to the root cause, how to find your root causes. Then also, see, let me actually pull up the Jenkins report. It's got a better, it does have, there we go. Okay, set's not working. Let me see what are some other ones. Basically, so it can also generate a coupling between objects class. So that way, if a class depends on more than 20 other classes, it can take and it will be able to identify those classes for you. And I think dual zookeeper Kafka. Let me see here. That's right. Here we go. All right, yeah. So here we go. Cool. This is Kafka. So I use Kafka. So I thought it'd be interesting to run it on Kafka. So as you see here, this is quite interesting. This provides a pretty clear output, a pretty clear listing of what you should do first. And then for the coupling between objects, this is what this report looks like. This only prioritizes again based on the number of classes that another class is depending on. And so this also is highly indicative of cycles that a class might be involved in. And so Kafka, the Kafka Raft client is definitely one that should be considered a high, have a high degree of technical debt that the Kafka team may want to take a close look at, basically. So yeah, that's the report output. I think that's about it. Is there anything that you'd like to dive into, or any ideas that you have that on how RefactorFirst could be improved? I'm all ears. I'd love to hear your ideas.
I have a question about your Git analysis or version control analysis. Do you persist any of that?
No,
so that
no, I do not.
You can reuse it on, in theory, your Git history shouldn't change.
Yeah.
So.
Right. Yeah, you're absolutely right. Yeah, and that is something that could definitely be done. You're absolutely right. So this is definitely something that could be incorporated. And I would love to. I've thought about that before as something that could be done to make everyone's life a lot easier and to reduce the analysis time. So yeah, I know it has been done for other Maven plugins like the dependency check plugin. I haven't taken a deep dive into that and to see how it's done, but I know it can definitely be done.
If you recorded the metrics that you calculate on each file or you could record the Git hash of that particular revision.
Which is really the timestamp, last commit.
Well, you have that as well, but if you had the Git hash, that would give you a handle to go fetch it on that path pretty easily.
Yeah, absolutely. Yeah, I haven't taken a deep dive into that yet. I'm just trying to get it working, get a proof of concept. This is still in its early stages, its early phases, but definitely something that I can definitely incorporate. Yeah. But thank you so much.
I have a question. Sometimes you're talking about you assume that everyone is writing an object-oriented program, right? What is the Groovy or Python?
No.
Where I've seen some consulting companies, we hire contractors, and they dump thousands of lines of straight line coding. So this is one of my pet peeves. I told all our CPMs. So is there a way to convert straight line coding into a object-oriented? Some other magic means like Chat GPT or something like that. What is the biggest where the actual logic resides in, so that you make us as a kind of create a small card class out of that?
A great
Yeah.
question. So Jim, I kind of just before you answer. So your what's your thing called RefactorFirst? That's your this is your baby, your company, your own thing, or is it open source?
It is open source. Yes. Yeah.
Okay, it's open source, and it's only currently dealing with the Java code base, right?
Yes, that is correct.
And this gentleman obviously asking that. I mean, you're not even dealing with the .NET framework, the C# world at all, right? Obviously.
Right.
Yeah. Okay.
Yeah.
So, and you are talking even about a non-object like command line. Actually, there's a lot
Groovy allows you to write hundreds of lines without a class.
And also in the I don't know how many in the data warehousing world, of ETL world, there are large files of SQL files or Hadoop SQL files, like thousands of lines of code. I'm sure there are lots of dead, and so that's where Jim, you can expand this on to a lot of places.
Oh yeah. Absolutely.
Go ahead and
absolutely.
Ask that.
Yeah.
Excellent.
Yeah, I mean, all you'd have to do, I mean, the Git repository analysis is pretty well solved as far as the functionality goes. The performance is a different story to some extent. I mean, I'd love to see it parallelized, but yes, to incorporate different analyses, it wouldn't be too much effort. I mean, like for Groovy, you'd have to add a Groovy analysis plugin, or add a Groovy set of Groovy analysis. For each of these, but for whatever metrics you wanted to incorporate, however you wanted to, just you have to, and then rank it accordingly, for example. But that's really about it. And then, so for I don't know about like for .NET or for say SQL, we'd have to write an analyzer or find one that could handle it accordingly. But that's really about it. But it's certainly not beyond their own possibility. Absolutely not.
Have you seen any tools being written or used that utilize like ChatGPT or any of the AI tools to like measure, even just measurement of readability of code? I don't know how well they would do. Hopefully they're improving if they're adequate. I mean, that's something that might give you some soft metrics on things that are a little more difficult to measure. With
that's interesting. I
How do
haven't
you
come
feel about
across that
uploading your
before.
code base to ChatGPT though?
If
Yeah.
ChatGPT can evaluate large code bases, which I don't think it can yet, they haven't turned it loose.
Well, I mean, we say that, but I mean, you look at something like GitHub Copilot, and they're taking and they're able to analyze and leverage all of GitHub.
Right. So if they expose GitHub Copilot and give an API to say evaluate the readability of this code, that might be another metric that you can incorporate in improving a code base, you know, factoring in the complexity and the, you know, the God class kind of aspects of it.
Yeah.
ChatGPT is just so extremely large. It's trying to encompass the world in terms of what it grab. You need more focused large LLMs, like, you know.
Exactly. Actually, what he pointed out, GitHub, what's the GitHub what?
GitHub Copilot.
So GitHub Copilot, I think the GitHub team, Microsoft already applied the LLM into it, right? That's the point, right?
Yeah.
I think GitHub Pilot is already did their homework of how to apply this large language model or the generative AI into it. That's an interesting question. I mean, James, yours is based on a couple of NSF-funded scholars, researchers, professors.
Yeah.
I mean, GitHub Pilot is based on probably many different things. They have probably bigger money.
Right. Yeah, but GitHub Copilot can't come up with new ideas.
Okay. Yeah. Have you played with the GitHub Pilot, as this gentleman pointed out?
Yes, I have. Absolutely. Yeah. It is nice. It's powerful. It's just pretty neat. Yeah. It saved me it saved me some time.
Does it a particular address the refactoring thing that you're trying to target?
No. What it does, it will make suggestions on what you should write, not what you. It won't identify God classes. It won't identify highly problematic classes for you. It's not a panacea. It's a code with a specific purpose. It's a tool with a specific purpose of accelerating developer productivity, basically, and to remove some cognitive load off of a developer. Like, for example, I was using it for Jackson mapping, for Jackson deserialization, and it came up with some pretty good suggestions that I wouldn't have thought to. It's the first time I really used Jackson, and so it was able to make some pretty good suggestions, basically.
What is Jackson?
Jackson is a JSON serializer and deserializer library. Both JSON and XML.
No problem. Yeah, that's all. I've never been in fun. I think
the difference between an LLM or like ChatGPT is it's a predictive modeling tool. It's predictive.
Yeah.
Versus this is a measuring and defining tool. The refactor.
Yeah. Mm-hmm.
This is actually measuring things and saying, okay, this is the result of that measurement.
Yeah.
This isn't predicting anything.
Mm-hmm.
So
The predictive part is okay. You've read this code. You've identified the issues. Now refactor it for me.
Yeah, that's the predictive part. Yeah.
Yeah, that'd be a pretty powerful use case. Absolutely. I mean, so that's definitely something that'd be really nice, really neat to be able to pull off. So there are one other scholarly paper that I came across. It uses effectively an artificial intelligence clustering algorithm that to group classes and commits. So that way, and it looks at to see if things that are the idea was to see if the things that are being changed together are also grouped together, basically. Because I don't know if you may not have heard Robert C. Martin, aka Uncle Bob, say what changes together should go together, what's used together should go together. So the idea there is to take and identify classes that are changed together but are not used together, or not packaged together, for example. So you can remedy your code base and get it healthier. What else? Another feature that I'm hoping to implement fairly soon is identifying dependency cycles between classes. So say for example, if these classes are highly dependent upon one another, so A depends on B, B depends on C, that we could take and identify those three classes as a dependency cycle, and then after that identify the minimum number of cuts to break apart that dependency cycle in some capacity, and point out which relationships to sever between which classes, so that the code base is not as big a ball of yarn, basically. So that's possible through use of something called a library called Java Parser, and another one called JGraphT. So somebody's actually written that code, and I've talked with him, and he's happy to have me include it into RefactorFirst. And so I'm hoping to include that in the future as a feature of RefactorFirst. And again, spit out a graph similar to this to prioritize it based on the churn or the relative the change proneness average across all classes probably, and then the effort, which would be the number of minimum cuts that would be required to break apart those dependency cycles.
Just a comment, Jim, the slide you're sharing with us on the screen is the Kafka code base analysis from your tool.
Yes, that's correct.
And there's so many great opportunities right in the land where you want them to work on, right?
Yeah. There really is. You're absolutely right. And also, it's worth mentioning that just as important as to know what to work on versus what to remedy is what to not work on. Like this stuff over here. So if you have an intern, well, I should go work on log context. Well, no, leave that alone. Don't fix that. As one of the I think the Dallas, the president of the Dallas Improving Office, David O'Hara, says, avoid the big rewrite. Don't throw it away. Avoid the big rewrite. So again, avoid wasting your time here, because these classes they're not changing. They're ugly, but they do their job okay. But it's things like standby task or task manager test, or the consumer group even. It does a lot of work, but it's being touched a lot, and so it's very likely that if you have an intern looking at that, they are going to struggle with how to actually tease it apart, what actually needs to be done. So ideally, what you want to get is focus on that class, because it's low-hanging fruit, like you said.
Good.
So is there a minimum sort of code base size that below which you find this is not useful, or?
No. So
you can use it anywhere.
Anywhere, yeah, anywhere is fine. There may not be any God classes present. So I do have a message for that. So it's a congratulations message. So so see, where is it? So either so if there's not a Git repository found, you'll need to go ahead and initialize one. And then if also at this time, the base project repository does need to match the Git parent directory. You could take and create a dummy POM file and then run the report. But again, if there are no God classes, I say congratulations. Your project has no God classes or has a couple classes, and then I also log that no disharmonies were found. So yeah, it certainly takes that into account. And it is possible that that if you and your fellow teammates decide, well, you know what, this has to be a God class, you can put @nopmd on the class and it'll be ignored by RefactorFirst. I can't say I'd encourage that, but if that's what you and your team really want to do, you feel is the correct answer, then so be it.
So Jim, what does the PMD stand for again?
Nobody knows.
There's something project mod load dependency or something like that. Program mod load dependency, something like that. PMD.
Okay,
It's part of the
all
Eclipse plugins.
Oh, okay, thank you.
Additionally, about
Thank
15
you.
years now. Yeah.
Yeah, thanks.
Yeah, so PMD is right here. So yeah. Yeah.
Code.
So yeah, I don't know. I think
It wasn't written by Paul, Manish, and David.
yeah, I don't know. So, but yeah, so again, these two are based on yeah. So the two smells that have been limited so far are collected from PMD, and you don't have to have PMD installed. It is available. It's bundled as part of the application or of the plugin, and so not to worry about that.
All right, thank you.
Yeah, you're welcome. Anything else? Any other questions, ideas, things you'd like to see in RefactorFirst?
So Jim, you're at Improving Columbus or in Texas?
I'm in Texas. I'm based just outside. I'm based out of the Houston office.
Oh, I thought we have an Improving here in Eastern Mall area, right? That's the same company, I assume, right? But Jim,
Ben can fill you in on that. Is Ben there? I think Ben can fill you in on.
He left.
Oh, he did. Okay. Bummer. Okay. So
yeah.
So Improving is definitely we do all sorts of consulting. We have Java development, Java consultants. We have .NET consultants. We have Agile coaches as well as Agile training, and we do a lot of Kafka work, and as well as just web app development. So I've done both.
Yeah, the only thing I know is here in Columbus, Ohio, so I thought it's a local company. Obviously, I'm wrong on that.
Yep. So Improving does have a Columbus office. We absolutely do.
Good. Yeah, actually, a lot of our local IT user group meetings are using their thing.
Okay. Yes, that's right. Yeah, Improving loves to host meetups, host user groups. I know that here in the Houston office is pretty neat. We have one called the Side Project Society that meets up regularly, and another one called the Houston Product Group. I forget exactly what he called it, but yeah. So all sorts of user groups and interest groups, things along those lines.
All right. So you're employed by Improving, but this is sort of your kind of extra work, hobbyist kind of thing, or this is part of the Improving your Improving is using your RefactorFirst.
No, this is the hobby. This is the passion project, basically.
Okay, great.
Yeah.
That explains the package name.
Oh, okay.
Org.h jug.
Yeah,
Houston jug.
Houston jug. Oh, okay.
Yeah.
So,
yeah, so that's what I named it.
I see where his yeah, okay. All right.
Yeah, so if you're curious. Yeah, so one of the other projects that I adopted initially was what was it? Not that one. Here it was not that one, sorry. Yeah, fine. I apologize, folks. A detangler. So if you're curious about it, it's a dependency structure matrix generator, and it'll take and it will generate a dependency structure matrix of your code base. It runs off of bytecode, and it's Eclipse licensed. I haven't improved it lately, but it'll run against Java 8 and I think maybe Java 11. But I haven't run it later. I haven't touched it lately. I've been focusing a lot on RefactorFirst. But that's I own the hjug.org repository at the time, and I still do. And at least I paid the bills for it, I should say. So I went ahead and registered it in the Maven Central, and was able to go ahead and publish this, and said, well, you know what? I already have hjug.org. I'll go ahead and publish RefactorFirst as well. And it made sense because it's also something that other HJUG members have gotten involved in as well. So it's been nice. I've really enjoyed it. But yeah, I'm always looking for. I'm always open to having other folks contribute to it if you want to. And I'm also leaning towards moving it to its own project as well, instead of living under Jim Bethancourt, since it has a number of stars and it has folks actively, it has other folks committing to it, to give it room to grow. And also, so I'd like to fork the Jenkins plugin as well and strip it down a little bit to suit my needs. So that would be another repository that would live in RefactorFirst. Things along those lines that would be able to leverage RefactorFirst, basically, or that RefactorFirst would leverage.
Yeah, great. Yeah, I mean, so yours is, your open source. Even actually, I could be totally wrong. You look at analyze the Kafka and a couple of other Hadoop stuff, and those are also open projects, but they're huge, and every industry, every Java people using them in some source. So can you imagine your RefactorFirst getting into that class of open projects that will become a bigger deal? I know you just started now, but what's the path for that possibility? Actually, I have no idea. But Kafka, there are so many classes. Are they actually only all the developers in their team, or I guess it's open source? How do they organize themselves?
I don't know. I know that Confluent is the lead author on a lot of the Kafka broker.
So maybe he was the first. Yeah, he was the first person like you at RefactorFirst. Then he recruited. Okay. Yeah. Thank you.
We're getting to the end of our time. You've been great questions.
Yeah.
Thank you very much, Jim.
Oh, my pleasure. My pleasure, folks. Thank you so much.